been said that operations research is the science of better. Now, I think a better world is an equal world where everyone has equal opportunities. That's why some of us at the University of Michigan are concerned that many people around the world don't have access to healthcare, which may lead to high prevalence of disease that can otherwise be prevented or treated. We find an example in Ghana, Africa, where it is estimated that 70% of the population is unable to use the official healthcare system because of prohibited distances. In rural Ghana, many population centers are dispersed over large areas. Furthermore, constrained resources don't allow for the installation of a number of medical facilities that can cover such a dispersed population. For this reason, many professionals addressing the problem have turned to mobile health facilities. To ensure the effective use of these resources, calls for an optimal tour to be found around population centers that can visit the most amount of patients with the least amount of travel distance, which can also be translated to time. Such a tour can be found by solving the coverage tour model, a mathematical optimization model that has been implemented in the context of Stochastic district in Ghana. India currently benefits from the use of a mobile health clinic that reaches patients in home-based. AmeriCares, a non-profit organization that runs the health project, indicates that the economic conditions don't allow people to seek medical attention. This would mean losing a day's salary, which is their only means of day-to-day subsistence. It is imperative that among so many patients, medical service should be scheduled to attend patients with the biggest need. This summer, I worked developing a model that, as well as the current tour model, finds a tour for a mobile clinic, but also increases the effectiveness by prioritizing patients according to their health situation and progress over time. At the heart of an optimization model is a goal expressed as an objective function that drives the variables towards their optimal value. Our model has the objective of increasing quality of life over the entire population. The model builds a tour for a determined future or planning horizon. Time is divided into time epochs, where each time a decision is to be made, which population center to visit next. This is a characteristic of a dynamic model. Dynamic models have another characteristic element, the state variable, which indicates the situation of the system. In our application, the state variable indicates the number of patients in every population center classified according to their disease severity. Future states indicate many possible outcomes that depend on their preceding state and action taken at that time. This way, we use a dynamic model to determine the sequence of visits that produces the best possible state at the end of the planning horizon. My name is Francisco Aldarondo, and I study at the University of Puerto Rico. This summer, I was working with Professor Mariel Lavieri and Zikian Shem from the Industrial and Operations Engineering Department at the University of Michigan.